Hi, hello everyone. So this is the video dealing with section 1.7, combinations and composition of functions. And this is the second part of the video where we talk specifically about the composition of functions. So in the previous video, we already covered the four basic combination operations, which is addition, subtraction, multiplication, and division. And now we focus specifically on composition. Now, the idea of composition is that we may evaluate a function of another function. So, for example, if I gave you a function f of x equals x squared minus 1, and I asked you find the value of the function at 3, or find f of 3, this is kind of what composition is. So what would you do in this case? Well, you would replace x with the value 3 and you would evaluate, right? So 3 squared minus 1, 3 squared 9 minus 1, 8. And that is the value, right, of f of 3. Now, a composition is nothing more than instead of evaluating the function at a particular point, we evaluate the function at another function. Instead of writing here a number, we write here a function. And this is what composition is, a function of another function. So here's the definition. So we call a composition of function f with g, and we represent it with this symbol. It's like a circle. So, and we say f compose g, and we represent it this way. So f compose g is equal to f evaluated at g of x. Now we can form any composition that we want. So for example, we can say f compose g, as you saw right here. We can say f compose f. Now what would that be? That would be f evaluated at f of x. We can do g compose g. Now what would that be? G evaluated at g of x. We can do g compose f. Now what would that be? That would be g evaluated at f of x. Okay? So we can do any composition that we want. And keep in mind that the function that comes after the composition is the one that is going to go inside of the parentheses here. The outside function, or the first function, is the outside function. All right, now let's take a look at some examples. I have some examples for us to do. And I've divided them into two types of examples. First, we're going to take a look at when we evaluate a composition and we evaluate the value of the composition at a particular point. Okay, and then these other ones, we just perform the composition without evaluating at a particular point. And then this is the special one where I wanted to show you it's okay to evaluate the function at the same function, right? So f compose f or g compose g, those are okay. It's just a function, all right? It's just a function of another function. All right, so let's take a look at the first two cases. So in these two cases, the first two, the answer is going to be a number because I'm evaluating the composition at a particular point. So what do we do? So first we understand the composition. So f compose h means f of h of x. And because I'm evaluating at a particular point, this would be f composed of h of 6. So the 6 goes inside this function. So the very first thing that I have to do is I have to evaluate h of 6. So here is my first in h. I have to evaluate the function at the value x equals 6. Well, all I have to do is replace x with the number 6. All right? So this is square root of 9 And in this case, I can simplify the square root of 9 is 3. If I could not, I could just simplify the radical or just leave it as a radical. Okay, so now I have h of 6. Then this question here becomes f evaluated at this, because this is my h of 6. So now I have to do f of 3, and you know how to do f of 3. So here's the function f, all right? Just replace x with the number 3 and evaluate what that is. All right, so that's 15 plus 2, 17. So f compose h evaluated at 6 is the number 17. Now let's do the exact same thing, but now instead of f compose h, let's do h compose f at 6 and see what the answer we get. So h compose f is h at f of x. And because I'm doing it at a specific value, is f of 6. So first I find f of 6 using the function up here, right? So I'm going to replace x with 6. So the function f is 5x plus 2. So 5 times 6, 30 plus 2, 32. So f of 6 is 32. So now I'm going to replace f of 6 with 32. So I need to find h of 32 using the h function up here. Well, the function is just the square root of x plus 3. So, but I already know what x is. It's 32 plus 3. So this is the square root of 35. And I cannot simplify that. It's just 7 times 5. Both are prime. So I can't simplify. I can't simplify the radical. So the answer is radical 32. So h compose f at 6 is just the square root of 35. So notice how different the answers come out. It's just two different compositions, right? We're forming a new function with a different composition. Even though they're evaluated at the same point, the function that comes first is different. So the answers are different. Okay, now let's do f compose f. And again, I could do anything. I could do f compose f, g compose g, h compose h, k compose k, any function that I want. It's fine. So f compose f is obviously f evaluated at f of x. Now, I'm not trying to evaluate it at any given point. All I'm trying to do is find the composition and leave it in x form. So first I have to find f of x. Well, I already know what f of x is. It's up here. All right, let me just clean this thing. So f of x is 5x plus 2. And now I have to compose that function with f of x. So this input has to go inside the f function. So this whole thing now is going to go inside the x. So now f compose f of x would be, right? So here is your f function. And this whole function is going to replace the x value. So this is going to be 5 parentheses, 5x plus 2 plus 2. And now I just have to simplify this. And this is similar to the combination of functions that we've seen before, right? So just distribute the 5. So I have 25x plus 10 plus 2. So this is 25x plus 12. So f compose f is 25x plus 12. Okay, so not really that bad. Okay, so, and again, I can do the same thing I did with F compose F, with G compose G, H compose H, K compose K, and so on and so forth. All right, in this case, it turns out that I wanted just to show you F compose F, so here it is. All right, now I am going to just erase this to clear this thing a little bit. And let's do the remaining compositions so that you can see how they are done. Okay, so I'm going to do F compose G, which is F evaluated at G of X. So the G function goes inside here. So I'm going to write it in a way that makes sense. I already know what this is. I don't have to evaluate it like in this case, right? I'm not evaluating at a point. So I am going to write the G function inside the parentheses right here. And I am given G. This is what G is. So I'm going to write it right here. Okay. So F compose G is just like composing F at 2x squared minus 1. Now, you know how to find, for example, F of 3. What would you do? You would get the 3, and you would replace x with it, and you would evaluate. So 5 times 3, 15, plus 2, 17. Instead of evaluating F of 3, we're going to evaluate F at this function right here, which is 2x squared minus 1. So instead of replacing x with a number, we're going to replace x with this whole expression. So let's do it. 5 parentheses, instead of a number, 2x minus 1, right, plus 2. And we just evaluate this. Now we know how to do this. So 5 times 2x squared, 10x squared, 5 times minus 1, minus 5, and then the plus 2. So and then we can combine the two numbers, 10x squared, minus 5 plus 2, minus 3. So F compose G is 10x squared minus 3. Okay. Obviously, notice that G compose F would not be the same value, right? And you can do this in your spare time, but I just want to clarify that it's not the same value. Okay, so let's do the next composition. I have to make this a little bit smaller because otherwise I don't see the function. Let's do the next composition, which is K compose H. So here is K, and we're going to compose with H. So just as before, I am going to replace H of X with its definition, which is radical x plus 3. So K in parentheses H x plus 3. So I have 2 parentheses here by mistake. So again, instead of finding K at a particular number, I'm going to find it at square root of x plus 3. So look at the K function. Here is the K function. And wherever you have an X, you're going to replace with square root of x plus 3. Okay, so I'm going to write it. I'm going to write it this way first so that you can maybe understand. I'm going to put this bracket here, plus 4 over 2. And normally, if I wanted to evaluate, right, again, K at 5, you would get the 5, and you would replace it here. But I don't have 5. I have this whole function. So this whole function is going to go up there and replace x. So this is going to be 3 parentheses radical x plus 3 plus 4 over 2. Now, there's nothing I can do here, right? Because the 3 doesn't multiply the x in the 3. It multiplies an invisible one that is outside of the radical. So this is going to be 3x plus 3 plus 4 over 2. And this is my final answer. Okay, there's nothing I can simplify. Do not simplify these two numbers. Cannot do that, okay, because of the plus sign that is right here. So this is just a composition K compose H. All right, let's do the next one. H compose F. So let's take a look. So here is my H, and here's my F. So before we did H compose F, and we evaluated at 6. Now we're just doing H compose F without evaluating at a particular point. So the answer is going to be a function. All right, so H, I already know what F is, so F is going to go in here, and F is 5x plus 2. And now I write the H function. So here's my H function, right? And I'm going to put a bracket here. You don't have to do that. I'm just showing you where the value is going to go to. So this whole expression is going to replace the x. So this will be square root 5x plus 2 plus 3. So this is my previous f function. And now if I can simplify, I can certainly add the two numbers, 2 and 3. So this is going to be 5x plus 5. So the composition H compose F is square root of 5x plus 5. And I cannot simplify any further, so it stays that way. All right, and the last composition, G compose K. So G is the outer function, K is the inside function, so I have to find G of K of X. So here's K of X. So 3x plus 4 over 2. So now I write the G function, and it's up here. Let me just clean this a little bit. So here's the G function. And again, wherever I see the X, I'm going to put a bracket here for you to see where the answer is going to go or the function is going to go in. So this is my G function. And everything in here is going to replace X. Okay. So let's see. I'm going to make myself some more room because this is going to take a couple of extra steps. So I'm going to replace X with this whole expression. So 2, 3x plus 4 over 2 square minus 1. All right. So there's a couple of things that we need to do, right? So I have the numerator and I have the denominator both have to be squared. So I'm not going to touch the 2 on the outside. So this is going to be 3x plus 4 square over the 2 square, which is 4. And then the minus 1. All right. Now, these I can simplify already. So I have 2 in the denominator. So I have 3x plus 4 square over 2 minus 1. Now I have to evaluate 3x plus 4 square, which I can do it on the side. I'm going to do it over here. 3x plus 4, 3x plus 4. So you do this on a scrap paper, and then you FOIL this, right? So 3x times 3x, 9x squared, 3x times 4, 12x, 4 times 3x, 12x, and 4 times 4, 16. And we combine these two, so I get 24x. So 9x squared plus 24x plus 16. So that replaces this. So I'm going to have 9x squared plus 24x plus 16 minus 1. And this is all over 2. So you could leave it this way if you wanted to, right? There's not much I can simplify, but I could do a little bit better. So this is going to be 9 over 2 x squared, 24 and 2, 12x, 2 and 16, 8, minus 1. And then I can combine the 8 and the 1. So 8 minus 1, 7. I'm just going to change it over here. So this is 7. So this is the composition G compose K. Okay, so sometimes this happens, right? You may have to simplify some of these compositions. Sometimes it's not possible. For example, when we did K compose H, we ended up with this, and there's nothing I can do here, right? There's absolutely nothing I can do. The only thing that you could do is write this as two terms, so it would be 3 x plus 3 over 2, and then separate, and then 4 over 2, and then this you could do, but it doesn't look any better than this one, so you can leave it in this format. However, this function here, this you must simplify. So the answer cannot be left in this format. You are required to simplify and leave it in this format. So this is composition of functions, right? We can do any compositions that we want, and the composition always looks the same way. First function compose the second function is represented this way. So the input of the second function, this is the second function, goes into the first function. So composition of functions.